Okay, question 3 from tutorial 6. Water is flow out of a overhead water tank through a smooth pipe opening at the ground level. So pipe is smooth and opening at the ground level as shown in figure. Now bottom of the tank is 20 meter above the ground level. So this part is the tank. Now bottom is this tank is 20 meter above the ground level, and depth of the water inside the tank is 5 meter. Now pipe diameter, internal diameter is given 50 millimeters. So this pipe internal diameter given 50 millimeter. Now determine the water flow rate expected at the ground level. So we need to find out the water flow rate, say Q, at the ground level. So if I write down the number top water level, say location 1, say this one 2, so we need to find out at location 2 how much the water flow rate, and there is some condition given. So neglecting the loss and assuming constant water level is maintained. So inside the tank at point 1, we will maintain the constant water level, and through inside the pipe, due to the water flow from tank to the ground level, there will be no loss. So two assumption given. So we need to find out the water flow rate. Water flow rate is basically we need to find out the volume flow rate. We define, say here they give you the, I think Q, this one, say Q2, it will be the equal to your area 2, so at location 2 area, that means pipe area. So pipe diameter given, we can find out the area, and at point 2 the velocity of the water. If you know these two, so we can find out the water flow rate at the ground level. So area 2 is easy, it will be equal to pi over 4 diameter of the pipe. So millimeter given, if you divide it by 1000, it will become the meter to the power square. So or here is sorry, the area is done. Now problem is the velocity. Now for in this case they give us the no losses, so we can use the Bernoulli equation, because when there is no loss at any 2 point, their summation of all energy will be equal to same constant. So we can write down, say when no loss are considered, so your total energy will be the summation of total energy will be the constant. Now if I apply the Bernoulli equation, say between 2 points, so one is at location 1 and location 2. Location 1 is on the top of the tank, location 2 at the ground level. So it will be equal to pressure at 1 divided by rho z, then velocity at 1 square divided by 2z, and potential energy part, it will be, say z1, say height. If we select the data, say this one is our reference point, so z1 will be from here to this point is your z1, basically 20 plus 5, so 25 meter, and z2 will be at the ground level. So look at reference point, so it will be 0 meter, because we select this point as a reference, equal to, it will be total energy as a 0.20. So pressure at 0.2, then rho z plus velocity at 0.2 square, then 2z plus z2. So this on the Bernoulli equation. So if I define, say, there will be three type of energy. First one is the flow energy, and flow energy part is P over rho z. Second one is the kinetic energy, is B square over 2z, and last one is the potential energy, is Z, is the height of the water. If you go to the lecture note, lecture video, you will see the details explanation given for each part. So now in our case, we select 2.1 is above the tank, another one at the ground level. Now in above the tank, pressure, how much will be the pressure? So this one, say you hold, so if I draw the cross-section view for this tank, so it will be, say this one tank, and they maintain up water level up to the top. Say your free surface is here, right? Then there is a pipe, and from the pipe you can see they mention here the water is flow through the smooth pipe at opening, say at ground level. Say here, say water at ground level, water is flowing, say from rejecting from here. So this one also to the air, so you can consider the free air, free surface discharge to the air, and this height is given 20 meter, and this one given 5 meter, and we select this one as our reference. Now you can see on the location 1, your pressure will be the 0 because the free surface. So here P1 will be the 0, P2 at here also 0 because your water discharge at the air, at the free surface is opening here. If this point is here is a close, then you at point 2 your pressure will be your rho gh, the density, the gravity acceleration, then height of the liquid. But here this one not closed, your pipe is opening here, so water discharging to the air, the pressure will be 2, will be 0 also. Now velocity, so at on the top layer, on the inside the tank upper surface, velocity will be 0 because water will be the rest, there will be no movement in here water, and also they give you the conditions, so we will maintain the constant water level. If you maintain the constant water levels at 0.1, there will be always liquid up to the 25 meter above, there will be no change height or nothing movement in around here. So your velocity 1 also 0, but velocity 2 is not 0, it will water will discharge from here with some velocity. So we will find out this too, we are looking for this velocity. Now z1, so we select the bottom as a reference, so z1 is 25 and z2 is 0. So now if I put the all values here, so z1 is 25, velocity square 2z, and z2 is 0, so only this part is remaining. So your velocity at 2, it will be root over 25 times 2 times 9.81 equal to, you'll get the 22.15 meter per second. Now we got the velocity, we already calculate the area for location 2, so we can find out the water flow rate at the ground levels. So your water flow rate at the ground level Q2, it will be the B2 times A2. So B2 is 22.15, A2 is pi over 4, 0.05 square equal to, it will be 0.0435 meter cube per second. So your final answer. Okay, thank you for watching. If you have any question, you can send us email or see you on tutorial class to discuss your question. Best of luck.